Down near the western horizon, the sun is setting. The day has ended, as the earth has turned us away from the sun and into its own shadow, what we call night. Above the glow of sunset, the new crescent moon appears. It is joined by the first bright stars of evening. We've waited the whole day for this chance to go outside to watch the stars in our backyard. We remembered to wear long sleeves and long pants. We're warmly dressed. We're far away from the street with its dangerous traffic. We've gotten away from bright streetlights too, and have brought along a flashlight and a lounge chair to sit back in to watch the stars. And oh yes, we've brought along a grown-up, father, mother, grandparent, aunt or uncle, so that we can show them all the things we've learned about the sky, and so that they can protect us and keep us safe when we're outside. It's a beautiful night. Let's see what's up there. There's the moon. The moon is round, but it seems to change shape over time, what we call the phases of the moon. And because the moon orbits the Earth once a month, it very slowly moves around, appearing in a different part of the sky each night. Sometimes it looks like a banana in the western sky after sunset. That's what we call a crescent moon. Sometimes it looks like a half circle. This is a half moon, which appears well up in the southern sky in the evening. Often the moon looks lopsided, like an egg in the sky. This is a gibbous moon. And when the sun lights up all of the moon, as we see it from Earth, we call it a full moon, which rises out of the east at sunset. After the moon, we see the stars. But some of the brightest stars up there aren't really stars at all. They're planets. The planets look like bright stars because they're so far away from us, millions and millions of miles out. But when we look at them with our telescope, we can see that they really are worlds in space. Venus goes through phases like the moon. Mars looks like a small orange circle. When we aim our telescope at Jupiter, we can see its 4 largest moons looking like tiny stars near the planet. And when we zoom in on Saturn, we discover its beautiful rings. All the other stars you see really are stars. They seem to be scattered all around the sky. But after you watch them long enough, you may be able to learn their names. And in time, many of them will seem like good friends to you. You will see some patterns of stars again and again. These special patterns of stars are called constellations. There's a very famous group of stars, a constellation we call Orion, the Hunter. See? You can tell that it's Orion because he's got those 3 stars in a row that make up his belt. Here are his shoulders, and here are his legs. And here's how we might imagine he looks. We can use Orion's belt to find other stars. If we draw a line along the belt and stretch it downwards, it will lead us to the bright star Sirius, sometimes called the Dog Star, because it marks the nose of Canis Major, the big dog in the sky. There's a little dog too, Canis Minor, just above the big dog. Its brightest star is called Procyon. If we go back to Orion's belt and draw the line upwards, it takes us to the star Aldebaran, the eye of Taurus the bull, who charges in the direction of our friend Orion. And there, on the back of Taurus, is a star cluster we call the Pleiades, the 7 sisters. They're kind of hard to see because of all the bright streetlights around us. But there are more bright stars to the east of Orion. Here are the Gemini twins, a long skinny box shape in the sky, marked by the stars Castor and Pollux, the heads of the twin brothers. And in the east we see a few more stars that look like a backwards question mark. That's the constellation we call Leo, the lion. The question mark shape is where we find his head and mane, and there are 3 more stars and a little triangle behind the question mark that make up his back and his tail. And there's a star group called the Big Dipper. Can you imagine it? 7 stars that make up the shape of a giant saucepan in the sky? These 3 stars are the handle, and these 4 stars are the bowl of the Big Dipper. Just off the Big Dipper's bowl, we can find a special star named Polaris, which is also called the North Star. It's not a very bright star, but it is always there in the north. The Earth's North Pole points toward that star. When we watch the stars, they all seem to be perfectly still in the sky. But the stars do move, slowly rising out of the east and setting in the west. It's really not the stars that are moving, but our Earth, which is spinning around, what we call rotation. It's only when we speed up time here in the planetarium that we can see this rotation directly, because for the Earth it takes a whole day, 24 hours, to do the same thing. All the stars are moving now, except for the North Star, which is right where we left it. That's why it's so important to us. The Earth's rotation causes day and night, as it turns the part of the Earth where we live to face first toward the sun and then away from it. When the sun goes down below our horizon, we rotate into a big shadow made by the Earth itself. This dark shadow is what we call night. Look, here comes the sun. The sun is too bright to look at directly, so we'll make it a lot dimmer here in the planetarium. We could never look at the real sun like this. The planetarium sun is now so dim that we can see the stars as well. These stars are like our sun, big hot balls of glowing gas, but they're very far away, and so the stars look very small and dim compared to our sun. What would it be like to go out there, up into space, to visit the sun, the moon, the planets, and the stars? Let's take that trip through space right now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Blast off!
Look, there's the Earth, way below us. It's a beautiful planet. Remember it when it's time to turn around and head home again. Our planet Earth, like all the other planets of our solar system, goes around the sun in a great orbit. The Earth revolves around the sun once each year. And as it revolves, we see sometimes the top half of Earth, where we live, is tipped in toward the sun, while at other times of the year, our north half is tipped more away from the sun. This causes us to have seasons. In the summertime, the sun is high in our sky. Days are longer, nights are shorter, and it gets very warm. In the fall or in the spring, the sun is a little lower in the sky, and days and nights are about equal in length. And in the winter, the sun is very low in our sky. The days are much shorter and the nights are much longer, and it gets cold. The sun is the source of all of our light and most of our energy. Without the sun, things would be very dark and very cold, and no one could live on planet Earth. Let's take a closer look at the sun, the nearest star to Earth. The sun is big. It's almost 1,000,000 miles across. The sun is a hot ball of hydrogen gas, over 10,000 degrees Fahrenheit on its surface and almost 30 million degrees at its center. The sun is so hot because it is so big and massive. 1,000,000 Earths could fit inside it. The sun's energy comes from hydrogen fusion at its core, more powerful than atom bombs, an incredible furnace of light and heat. That's our sun. As we move outward from the sun, we find the other planets of our solar system. There's Mercury, a small barren rock not much bigger than our own moon. It has lots of craters, just like our moon. Mercury has no air, and at nighttime it can get very cold. But when the sun comes out, temperatures rise to over 800 degrees. Venus is the next planet out. Nearly as large as Earth, Venus has continents, volcanoes, and mountains, a lot like our planet. But Venus also has thick, unbreathable air made of carbon dioxide, which turns sunlight into scorching heat. Venus is even hotter than Mercury, hotter than a pizza oven. Next out comes good old Earth. Oh, and there's our moon, traveling around the Earth once every month. As the moon revolves around us, it sometimes passes directly between the Earth and the Sun. When that happens, we have a solar eclipse. When the eclipse is total, we can see the Sun's outer atmosphere, the corona, shining out from behind the dark moon. And sometimes the moon revolves into the Earth's shadow, which makes a lunar eclipse. When the moon is completely inside our planet's shadow, it often looks very dark and red. The red color is caused by sunlight that is bent through the Earth's air and reflected off the moon. It's the Earth's gravity that makes the moon travel around us in an orbit once each month. But everything has gravity, even the moon. It's less than the Earth's gravity. But does the moon's gravity do anything at all to our Earth? Yes. The moon's gravity causes tides in our Earth's oceans. Twice each day, the water in the ocean gets higher and higher as the Earth rotates underneath. High tide. And twice each day, the water gets lower and lower as our part of the Earth turns away from the moon. Low tide. On any night that you see the moon, you'll notice that there are light and dark patches on it. We found out that the dark spots on the moon are really dark-colored rocks called basalt, like the rocks we find at the bottom of our ocean. And the bright spots on the moon are made of light-colored rocks called granite, like the rocks we find on mountains on Earth. Many years ago, astronauts from the United States went to the moon and brought back hundreds of pounds of rocks so that scientists could study them. We found out a lot of interesting things about the moon. We know that the holes in the moon, called craters, were made when big space rocks, called meteoroids or asteroids, hit the moon. Look at all those craters. There must have been a lot of asteroids floating around long ago to make that many holes. Earth has one moon, but if we go a little farther out, we can find another planet with 2 moons. These moons are very small, only 10 to 20 miles across. They look like big flying boulders or asteroids, and they orbit the planet Mars. Mars is about half the size of Earth. It's called the Red Planet. On Mars, there are big mountains like Mount Olympus, an extinct volcano over 15 miles high. And there's a huge crack in the ground called the Mariner Valley. It's nearly 5 miles deep, over 50 miles across, and 3,000 miles long. We've got some great pictures from the surface of Mars. It really is a red planet. The rocks are red because the iron in them has rusted. It's actually pretty cold on Mars, much colder than any place on Earth. And there's hardly any air there, and it's also the wrong kind of air for us, carbon dioxide. Mars would take your breath away. Before we get to our next planet, we have to cross several asteroid belts. There are millions and millions of rocks out here between Mars and Jupiter. They're leftovers, we think, from when our solar system formed long ago. But there are also asteroids that are much closer to us, and sometimes they run into the Earth. When they do, our planet's atmosphere makes the smaller rocks and dust burn up, and we can see them as shooting stars or meteors, little bright streaks of light in the night sky. But every so often, a large rock travels to Earth. It makes a bright flash of light in the sky, a fireball, and the rock can even hit our planet to become a meteorite. Is it possible to travel through an asteroid belt and not hit a rock? Yes, we can do it, because even though there are a lot of rocks, there's really a lot of space between them. many of our spaceships have made it safely through these rock fields. We are now 500 million miles from the Sun. A massive object lies ahead. It is Jupiter, the king of the planets. No other planet is anywhere near the size and mass of Jupiter. It is huge. It's wider than 10 Earths put together. We can't land on Jupiter. It's just a big rolling ball of gas with no solid ground. And there are storms in Jupiter's air, like the Great Red Spot, a hurricane 3 times bigger than Earth, and with wind speeds of 400 miles an hour. Now, we could land on one of its moons. There are dozens of them. Many of the moons are very small, like Amalthea, which looks kind of like an asteroid. But some of Jupiter's moons are gigantic, like Ganymede, which is even bigger than the planet Mercury. If you land on this moon, Callisto, be very careful because Callisto is made out of ice and covered with lots of craters. Europa may have liquid water deep down under its cracked and icy surface. And the moon Io has lots of exploding sulfur volcanoes. Whew, what a smell! The next planet out is Saturn, and it also has dozens of moons. Most of them are very small and made of ice, like Enceladus, and Dione, and Mimas, which kind of looks a little like the Death Star on account of that big crater on it. Saturn's biggest moon is Titan, and it has nitrogen air, just like Earth. But this air is far too cold for us. We're almost 1 billion miles from the Sun. Saturn is over 9 times the size of Earth, and it has those beautiful rings. The rings look completely solid, but if we could get closer to them, we'd see that they're really made up of lots of chunks of ice. Most of these ice chunks are so small you could hold them in your hand, but some of them are as big as a house. Another 1 billion miles beyond Saturn and its moons, a cold blue planet orbits the Sun. It is Uranus. This lovely blue planet is about 5 times bigger than the Earth, but the blue color isn't water, it's unbreathable methane gas. Uranus is a very weird world. It's tipped over onto its side, and so it revolves sideways around the Sun, like a big rolling barrel. There are very thin rings surrounding Uranus, covered with some dark stuff, carbon, kind of like charcoal. Uranus also has plenty of moons, although not quite so many as Jupiter or Saturn. The strangest moon is named Miranda. The most incredible thing about Miranda is this big ice cliff. It's several miles high, and if you dropped a rock off the cliff, it'd take maybe 15 minutes for the rock to fall all that way straight down to the bottom. The last big planet in our solar system is Neptune. It's also several times bigger than Earth, and it also has thin dark rings, and often there are big storms on it like we saw on Jupiter. Neptune has many moons too, including Triton, which is very cold, about 400 degrees below zero. It's so cold that big fountains of nitrogen ice shoot up out of cracks in the ground. And now we come to the world known as Pluto. Pluto is very small, not even as big as our own moon. Even though it's small, Pluto has 3 moons, including a big one named Charon, which is about half the size of Pluto. Beyond Pluto, there are more icy worlds, some as big or bigger than Pluto. Standing on one of these frozen worlds, we could look back and see the Sun as just a very bright star in the nighttime. Much farther out, way beyond the planets we've seen so far, there are billions of chunks of ice and rock. These are comets, which completely surround us. Sometimes these ice chunks fall inward toward our part of the solar system. When comets get close to the Sun, their ice melts, and they form beautiful tails that can stretch out for millions of miles. One of the most famous comets is Halley's Comet, which was last seen in 1986 and won't be seen again from Earth until the year 2061. How old will you be when Halley's Comet returns? Now way, way out, there are the stars. The stars are like our sun, but very far away. One of the nearest stars to us is the dog star, Sirius. It's about 9 light years away. 1 light year is almost 6 trillion miles long. So 9 light years means that Sirius is about 54 trillion miles away, and that's a nearby star. If a spaceship could go as fast as 100,000 miles an hour, it would still take over 50,000 years to get there. That's far out. But most of the other stars are even farther out. Space is really, really big. Stars are normally round, like our sun. Some stars are very small and cool. Some are very small and hot. Some stars are very big and cool, and some stars are very big and very hot. And there's even a kind of star that you can't see at all. We call these invisible stars black holes. What is a black hole? Well, it's a place in space where the gravity is very strong. So strong that nothing can get out of it. Not a rocket, not a spaceship, not even the light from a star. This black hole used to be a very big star, but it ran out of energy, and its gravity squeezed it down to a tiny point in space, a point of no return. We can't see these invisible black holes, but if we came near one, we'd probably find a lot of hot, glowing gas swirling around the black hole, and super hot X-rays created here would pour out into space, alerting us to its presence. Black holes are dangerous things. It's lucky for us that the nearest ones are trillions of miles away. Where do all these stars and planets come from? Well, up ahead we may have an answer. A really, really big cloud of gas and dust called a nebula. Outer space has lots of nebulas like this, and this cloud, the Great Orion Nebula, can be found below the belt of Orion the Hunter. Inside this cloud there are lots of stars, and we think that the stars are being made out of the gas, which is squeezed together by gravity. We think this is how our sun and planets formed almost 5 billion years ago. There are other space clouds that mark the places where stars have died, like the Ring Nebula, or the Helix Nebula, or the Cat's Eye Nebula. The Crab Nebula in the constellation Taurus is all that's left of a supernova, a star that exploded. But this only happens to the really big, massive stars. Our sun will never blow up like that. How many stars are there? On any clear dark night you can see thousands of them. But there are even more stars than the ones you can see, some so far away that you need a telescope to find them. When we look at some places like the Pleiades, we see hundreds of stars all clustered together. And we've also found some globular star clusters where there are 1 million or more stars. Everything we've seen so far is inside something we call a galaxy. The galaxy where we live is called the Milky Way. And when skies are really dark, we can see one of its arms. It's a faint band of milky light that stretches past the Big Dog, past Orion and Taurus, and across the whole sky. This is only one part of our galaxy, and we're looking at it from the inside. If we could travel outside our galaxy, we could look back on it, and we think it might look like this. So many stars, and so incredibly huge. The Milky Way is over 100,000 light years across, 600,000 trillion miles. And when we try to find our own sun and our own solar system, we can't. We're lost in the stars. We've discovered, though, that we don't live in the middle of the galaxy, where all those stars are. We live about halfway out, inside one of these big pinwheel arms of stars. And beyond our Milky Way, there are more star cities, like the Andromeda Galaxy, about 15 million trillion miles away. And even farther out are more galaxies, billions of them, And all of these galaxies have millions or billions of stars too. Wouldn't it be wonderful to keep on going on out on our trip through space until we'd seen all the stars, all the planets, and all the galaxies in our universe? So much to see, so much to discover. But for now, let's head back to Earth and the planetarium. And if you ever want to travel out into space again, remember that all of this is out there, waiting for you. Every time you read a book about astronomy, or ask your teacher or your parents a question about outer space, or each time you go outside at night to look up at the stars in your own backyard and wonder about all that is up there.